Okay, it is 2:15. Welcome back to the Peatlands Gathering. This is going to be session 4. I'm going to be your chair. My name is Florence Renou-Wilson from UCD, and I'm a peatland scientist, as well as I've been working with peatlands for the last 25 years. I set foot on my first Irish bogs 25 years ago with John Feehan. And I suppose the science since then has been really changing. But what I would say, just as a short intro to this session, is what's important is that we are interdisciplinary research across science and humanities. So today we're going to, this session, in the next hour, we're going to look at peatlands with mostly carbon and climate, but also conservation. And we have great presentations there. And without much wait, I just want to say a little bit of housekeeping. The Q&A is solely for the questions. So if you have a question, please put it in the Q&A for the speakers, and then you can just put your chat and response and comments on the chat. So don't put your comments on the Q&A, please, just your question. Okay. I have Ken Byrne is with me there taking notes. Thanks, Ken, but he's also actually the first presenter. So Ken, if you want to upload your presentation there while I introduce yourself, or I don't think there is any need for much introduction. Ken is joining us from University of Limerick, and will be giving us an overview of the carbon cycle in Irish peatlands. So Ken.
Can you see my presentation, Flo?
Yes, just make it, yeah.
Yeah.
Oh,
so
wait a minute,
just do that. So you have it now, yeah?
Yes.
Do you have the proper full screen view of it, Jess?
Proper full screen view, okay. Fire away.
I'll begin. So good afternoon, everybody. Thank you for your introduction, Flo. And my name's Ken Byrne. I work at the University of Limerick, and I've been around peat for many years. So what I'm going to do now is give an overview of our knowledge of carbon cycling in Irish peatlands. It's not an exclusive overview. I'm going to outline where the major knowledge is and some of the knowledge gaps. And if I misrepresent or get anything wrong about the work that my colleagues in other institutes have done, I apologize for that. All errors are mine and mine alone. So moving along, just to remind ourselves why carbon cycling in peatland is important. Well, you know, our peatlands, just like peatlands elsewhere, and as John Connolly illustrated in his presentation this morning, are very carbon dense ecosystems. We have at least half of our soil carbon stocks and 20% of our landscape. And of course, the use of peatlands is, and particularly for peat cutting, is deeply embedded in our culture. We've heard much about that today. And we've used them for lots of other purposes. And that conversion to some other purpose often involves drainage, and drainage is a death knell for a functioning peatland. It removes the very conditions that make the peatland possible and the accumulation of peat possible. So let's have a look. First of all, the big picture, rather than getting into the specifics of the numbers. These are from some work Florence did a few years ago. They illustrate the scale of our impact on these ecosystems over long periods of time, but they also, you know, as the last row indicates, that there's opportunity out there as well to restore, rehabilitate, or to think more carefully and implement new ways of taking care of these ecosystems. Natural peatlands are a very small part of the landscape now, but nevertheless provide a really good reference for where we were at and perhaps indeed where we could be in the future. For blanket peatland, the longest data set comes from a site operated by UCC for many years with eddy covariance measurements at Glencar in County Kerry. I believe it's one of the longest such data sets in the world. And this work demonstrated very nicely that there's about half a ton of carbon sequestration taking place, but the value of a long-term data set is really illustrated by this, where it reveals the interannual variability that occurs over a long period with big difference between highs and lows. There may well be an error there in that 32.1, excuse me. The sink higher in wet years and lower in dry years, and then some chamber measurements also conducted that show CH4 emissions. Other work important too at Clara, County Offaly and Abbeyleix Bogan, showing again that in the middle of the bog where the disturbance is least, that a sink operates, but as you get to the drier margins, there's losses. And just to note, there's ongoing work there, and Matt Saunders will probably mention that in his presentation later. Please also note my sign convention. In my thinking, I like to think of a plus being a gain for the ecosystem and a negative being a loss. Cut over peatlands. David Wilson has done work at a place called Moyer Wood for many years, and again, just really reiterates the point that when you drain, you lose carbon, CO2 losses, and again, drainage of bog margins, losing CO2. And indeed, just to show a bigger data set, this is work David also did back in 2015 and shows emission factors for industrial cutaway. And you can see the typical numbers here across a range of sites in Ireland and a few from the UK. So, around 1.64, which is a useful number to keep in mind. Okay, but the overriding narrative here is one of loss. Drainage leading to degradation of the ecosystem. And indeed, if we go to farm peatland, work done by Florence, you can see that as well, and it reveals some of the differences between sites. We have nutrient poor sites, nutrient rich, and nutrient poor. There's deep drained and shallow drained. If we look at the CO2 here, for example, shallow drained, some loss, but deep drainage, lowering the water table further, facilitating more oxidation of peat, and not surprisingly shown in the higher losses of CO2. And nutrient-rich sites, perhaps with more nitrogen or previous agricultural activity or nutrient inputs, losing very large amounts. And perhaps these are the sites that should be targeted first for rewetting, because there's not only is there the greatest loss, but there's the greatest opportunity for gain or to slow down. And I'm not going into details about DOC losses, but just to mention and bear in mind that it's a significant part of the carbon balance, which we really need more information on. There is work going on currently, and it'll be very valuable. And again, I haven't mentioned N2O previously because it hasn't been of huge significance on other sites, but in the nutrient rich one here, it is too. Okay, so
2 minutes remaining, Ken.
Thank you. Forestry. Here's a recent piece of work by a PhD student of mine, Honai Hovani, and we did a full soil carbon balance for a number of sites forested in Southwest Ireland. So litter inputs, fine root inputs, carbon loss from soil. And we found that for the most part, these soils are losing carbon. So note my things, and DOC loss is not included there. A couple of examples of rehabilitation, rewetting. So there's the opportunity to slow down CO2 losses. Okay, just look at the trend in the numbers across here to illustrate the gains that can be made. And we know the scale of the numbers this nationally and the great opportunity that's out there to make reductions. There's some more work from a PhD student of mine where we looked at rewetted, formerly forested bogs. So they had previously been managed by Coillte for forest and cleared. And well, it's not so simple here. These are still CO2 sources. But note here, the cladonia is a sink. So there is an opportunity, but depending upon the vegetation. So I'm just saying we need to proceed carefully with regard to this. My closing slide. I've gone rather quickly as necessitates. So our overriding impression from what we know is that drainage and land use change alters our peatlands from carbon sinks to sources. Rewetting could slow that down, but please note that I mentioned patience. It takes time, it takes time. And we've got to stay the course with this to see it through to the right end. Our flux studies, they're based on sites, and at least in my impression, we don't know how representative or often how representative these are of the national scale. So we need a bottom-up, top-down approach where we know what our sites mean, what the context of them is, how they relate to the national picture, but our national picture then needs information that filters back down and connects to those site level investigations so that we can tie the two things together and know what our sites mean. And also one point is our emission factors are static. Hopefully we can get past that. There's lots of new work ongoing that other people are mentioning, and lots of people are giving great presentations about the work in this regard before and yet to come. Modeling, of course, is always mentioned. So I'll pause there. Thank you all so much. I hope this has given a useful insight and tease up all the other presentations, if I could claim that for myself. But so many interesting presentations going on, and I hope you're enjoying it. Thank you. Thank you very much, Flo.
Thanks. Thanks, Ken. Thank you. Yeah, that was great to start the session. A lot of sort of crunching of data already there, but as you said, more is needed as usual. So in fact, speaking of more, that's a good segue to Shane Regan from National Parks and Wildlife Service, who is going to talk to us about the great development there on the monitoring network on their sites. So Shane.
Yeah, thank you, Florence. And yeah, thank you, Florence. Happy to speak today. And yeah, I think this ties in nicely actually what Ken was talking about, trying to build up a national picture of where we're at, what we need to know, and where we can go with that. So on that basis, over the last couple of years, we've begun to develop some sites for greenhouse gas monitoring and ecohydrological monitoring, and trying to compile that as some sort of network across Ireland. So this is just from the MPWS work that we've been doing, and hopefully we can integrate that with the other work that's been done in institutions like Limerick and TCD, etc. So the network, it's inspired by eLiter, and if you're not familiar with that, it's a network that was formed in North America, long-term ecosystem research. And basically the kind of concept behind that is that, you know, ecosystem processes are long-term, and we know that, and you need long-term observation of ecosystem phenomena. And the idea behind that is that if you can focus your research on a set of representative sites that are well equipped and they monitor different aspects and different components of the hydrological cycle, for example, you can then, you know, detect phenomena that you would not get in fragmented research, i.e. research that's conducted over 1 or 2 years, or, you know, is geographically isolated, etc. And this is being developed actually at the moment by Owen Nocton from Carlow IT. He's building a business case to maybe administer that in Ireland. And just to come back a little bit to peatlands, what I call the problem with peatlands, and this has been said repeatedly over the day, is that, you know, peatland ecosystem collapse, and I think we are at the kind of in the collapse stage. If you look at how much of our peatland is actually in a good condition, you know, it brings its environmental risks, and as we know, I mean, drained peat, it released biological and chemical constituents that were otherwise sequestered and had been for thousands of years, and that is released as emissions of CO2, as ammonia into watercourses, and that has other impacts. In Wicklow, for example, you're getting rivers with very, very low pHs in the order of 3 or 4. So it's acidification that's going to impact freshwater ecology, and also endangers human health, considering we still treat water with chlorine, and a lot of our water comes from peatlands, up to 70% in fact, and that's going to result in THM. So there's a lot of different components to that. I won't dwell on this. We've seen this map a couple of times. So it's a brilliant map developed by John. We're all using it. What I want to just draw attention to is that even though we've a lot of peatlands, 20–25% of our land surface is peatland, only 17% is conserved as SAC or SPA or NHA by the National Parks and Wildlife Service. And of that 17%, I mean, of the raised bog network, maybe less than 1% of that is actually accumulating and sequestering carbon. The blanket bogs, we don't know as well because they haven't been mapped to the extent that the raised bogs have, but you're probably talking about 10 or 20% is in a really good condition. So I mean, that's a pretty poor, representation of peatlands in Ireland being good condition, and it covers a big area. Numbers computed by Fernando estimates it's between 1.2–1.5 million hectares. And to put that another way, that's about 1 billion tons of carbon stored in the ground. And as has been said before today, you got to keep that carbon stored in the ground. So in terms of monitoring is really important because it allows you to detect change and to interpret why that change happened. And just as a means of an example, it's just some work I've done on Clara Bog, and I'm sure most of us are aware of Clara Bog. And there was work done there in the 80s by a series of Dutch, Irish, and other ecologists and hydrologists and this type of thing. So but the good thing about that study is that there was records of topography, hydrology, and when you look at Clara over time, it's changed dramatically. Topography has changed because of subsidence, the ecology has changed, and we can track that to basically changes in water level, and that's actually to do with drainage of the regional groundwater. That's kind of drainage outside of the bog itself, and we begin to interpret why that happened and what that means in terms of management. So monitoring is essential because you want data to understand the ecosystem stability, how resilient it is to change, and then to observe those changes to structure and function like we have done at Clara, and to apply that data for conservation. I mean, what do you need to take into account when doing a conservation assessment? What are the restoration criteria for damaged systems? For example, what water level do you need to get to get back your carbon sequestering conditions, and then to develop some ecometrics. And on that, there will be a report coming out soon from myself and Lawrence Gill, and we've developed ecometrics for raised bogs, turlocks, and fens. And just to give you an example here on the right, it's just a simple flow duration curve for a river. And basically these guys in the States kind of, worked out the kind of Goldilocks, state or hydraulic state for the fish they were looking at. And then, to try and determine when you have a deficit and where you're surplus, that might impact its ecological functioning. And again, you look at the hydrological regime, you might have an erratic regime, like a flashy stream up in the uplands, or a more persistent stream where you've got storage in the catchment. I won't dwell on this, but if you look at these papers, they'll give you an idea of what that means. There's a lot of
remaining, Shane.
There's a lot of policy drivers behind that. There's the Habitats Directive. We declared a biodiversity and climate emergency. So to address that, we do need this network. We also need to monitor it in a holistic way. And we look at, say, an ecosystem in terms of a catchment, it's going to be influenced by all of these processes. So you got to measure that. Different meteorological variables, the water level variables, runoff, flow rates, biology, etc. And these are just some flumes and boreholes we can put in the past few years. And using that kind of information, we've been able to quantify the change of Clara in terms of its change in runoff. And in terms of the carbon, I mean, you can measure it with the eddy covariance and flux chambers. And at Clara, we were able to kind of correlate changes in hydrology to changes in the carbon balance. And we find that when you take into account, say, the hydrology, the export of water is DOC and DIC, it changes what you would think might be a moderate carbon sink into actually a carbon source. And in terms of long-term monitoring, this is some work done in Canada by Nigel Roulet. Over 20 years, he's been measuring a particular peatland site, and it's actually sequestering more carbon than it used to because it's getting warmer. However, that peatland retains its moisture where ours do not. So in terms of the network, currently, we're looking at Clara. We've done a lot of work. Matt now has a flux tower on, which we'll talk about later. We're looking at a series of cutover habitats, Killyconny Bog in Cavan. Willie Crowley just published a paper on this, and we're basically looking at his ecotypes to do greenhouse gas measurements. We're looking at a transition mire up in Roscommon. That's the transition between the fen and the bog, and that's sequestering a lot of carbon, we feel, at the moment. And we also have an eddy covariance tower set up at All Saints Bog, and this has flumes and piezometry, etc., and we're tying that all in together. flux towers, flux chambers, and there's also other sites going to be incorporated from Byrne and Mona as part of the PCAS scheme and TCD, and this is some preliminary results from All Saints. We're also beginning to look at the uplands. So in wild Atlantic nature, we're going to be putting up a flux tower there together with the other instruments, probably at a site that will be or deforested, I shouldn't say afforested, deforested, and look at the impact that that has. And more recent times, we've got a project with Intel. I think that might be the first of its kind where we're working with a multi-corporation company because they're interested in water resources because it cools their plant, etc. So we're looking at doing some studies, and we are currently doing some studies at Liffey Head Bog, looking at different components there too. So the aim of the network is to kind of just establish a stable monitoring system, basically to standardize the quality of the data that we collect and ensure that the monitoring is maintained in the long term. When I say long term, I'm thinking 10 years plus, and use that information for policy and help us meet our strategic demands. So I would put the question, to maybe to researchers in the room. I mean, when you're doing this type of work, I would always be thinking, what kind of data do we need, say, in a policy environment to make a decision? And we've used information from the carbon studies to actually do an enormous amount of restoration. Ken mentioned at the start about half a ton of carbon sequestered per year in an intact bog, whereas maybe 3 to 6 tons is emitted from a drained bog. But when you feed simple numbers of that like that up the line, you can make a big impact. So long monitoring is essential. I want to make this data available to all scientists, and of course for modeling studies, remote sensing, that kind of thing. Okay, I've probably gone a little bit over. Apologies, Florence.
Thanks, Shane. Okay, no, it was a very good comment you made there, and I think we'll discuss that again. At the end, I have actually one such question for the panel anyway. So let's move on. Thanks, Shane. So our next speaker is doesn't need any introduction either, because if you've heard about Abbeyleix, you've heard about Chris. So Chris is our next speaker to talk about community-led conservation and climate action. Chris, go ahead. Thank you.
Thanks, Florence. I hope you guys can hear me. I'm just going to run through this quick presentation, see where communities get involved with climate action, and basically see how this fits into the bigger picture. That picture, obviously, I think is what community-led conservation is probably all about, is connecting people to their natural environment. Anyway, I'm going to use the Abbeyleix bog just as a quick case study for the points I want to make. First of all, it's a 2 square kilometer site where basically evidence-based restoration and conservation is taking place at the moment. And that is done by using ecological surveys, a variety of them over time. We also do continuous monitoring and data collection through partners and people that is involved with the project. We also use citizen science, and the community, this is all done through a community-led management, and that is for the common good. Now, how does the community do that? We do it through events and different workshops. We also build infrastructure with volunteers. We involve the visual and performing arts. We also, and all of this is done with stakeholder collaboration. We don't have all the knowledge. We're bringing people in, and they help and support us with this. So all of this work and everything is done has a benefit to the different habitats that is involved in the project, whether it is the bog, but also all the ancillary habitats around it. And not when you have an impact on the habitat, you have an impact on biodiversity. This also have an impact on the recreational and well-being, because we provide that facility for people. And then also it has a socio-economic benefit. But here's my message. Conservation is complex, but it should be linked in. Ecosystem management should be linked in with human well-being. And to do that, that should be the most effective would be a multi-stakeholder, multi-linkages between different partners. It can't be done by just government central or just by community-led. And to do that, let's look at the recommendations by the Water Forum in terms of community and public engagement. Include communities right from the beginning in the decision-making, the power relations should be addressed in the participatory process, and we need to the importance of regulating and accountability of the stakeholders. And then obviously it is all built on trust. And then the last thing is we need interdisciplinary knowledge and sharing, whether it is research, whether it is work done on the ground, or it's by community information. I hope that gives you a good idea. And I just, this quote has come up earlier as well, but I think we need to move away from seeing our environment as a commodity, but more a community to which we belong to. Thank you so much.
Thank you, Chris. I'm just coming back in here. We have a few minutes. If you want to say something else, Chris, or tell us maybe how we came to in Ireland. What like for someone who wants to know? Well, you know, we came a long way. I think you maybe there's something you want to tell us, but you know the history, like over the last 10 years, especially
of the project, I presume.
Yeah, like how we in Ireland, you know, like if you want to compare 10, 20 years ago and now, we have come a long way, though, to bring in community is just, there's still a lot of work to do, of course. Yeah,
20 years this project is on the go. So 20 years ago, we people looked at us with two heads, if we have two heads, and there was really no support or any input from the big stakeholders in this, not even National Parks and Wildlife Services, not the local authorities. We had to basically kick can and kick people's backsides to a certain extent. It is only recently, in the last 5 or 6 years, that the whole community engagement issue has come to the fore, and there's a realization that it is important and it plays a key role, because you can do all the climate action you want, and you can do all the biodiversity protection you want, but if it is not linked in with the broader social issues, with the community, with well-being, with economic, social well-being, you add nothing. And I think that is where the local community, and not only community of location, a town or a village, but also community of interest, which this Peatland Gathering is. It's a big peatland community. It's important to bring everybody together.
Thanks, Chris. Yeah. On that note, and for going back to the climate problem with peatlands now, we have Matt Saunders from Trinity College Dublin, and continuing on monitoring the importance of measuring greenhouse gas, but also the holistic way of doing it to address climate action. Thanks, Matt.
Okay, thanks, Flo. You can hear me okay?
Yes.
Yeah, brilliant, thanks. Okay, thanks everybody. So I'm going to add to the conversation that you've heard a lot about today in terms of peatlands and the climate piece. And I'm going to focus in on some of the work that the current SmartBog project is doing that's funded by the EPA. And I'd just like to say, to start out with, this isn't done in isolation, and there's a huge range of wonderful people you can see there on the title slide that I'm working with as part of this project. So I've just popped this graph up because I think it's quite useful to actually illustrate lots of things we've been talking about today in terms of the impacts of peatlands on climate, and how, as you degrade an ecosystem such as a peatland, or if you potentially rehabilitate an ecosystem, what the potential is there for the emission savings that can be made in relation to carbon and greenhouse gases. And that's important at the moment. I mean, if we think about the policy perspective, it's important to start thinking about how we report these numbers, as Shane mentioned in previous talk there, you know, how we report these numbers, how we use these numbers. And that's something that the SmartBog project is really trying to do, using a range of different approaches to really assess the impacts of, I guess, peatland degradation, largely through drainage, but also looking at some aspects of land conversion and how that really influences carbon and greenhouse gas dynamics. So what's the project really trying to do? Well, we have a number of different kind of approaches here. The first is to look at really, well, where are the peatlands and what condition are they in? And you've heard a little bit about some of this work this morning that John Connolly and his team in TCD, Wahaj, are working on. And they're using a range of Earth observation types of data, as well as other mapping approaches to understand, well, where the peatlands are, you know, what sort of land uses are they being used for, what sort of kind of pressures are there. We're looking at new novel approaches to map drainage extent, and then to figure out how that influences the hydrology and the ecology, and then how that influences kind of key things such as the biogeochemistry, and in particular the carbon and greenhouse gas dynamics. In addition to that, we've got a number of sites that we're looking at these systems. Are these ecosystems net carbon and greenhouse gas sources or sinks? And we're using a range of approaches there, ecovariants, chambers, flumes to measure the fluvial export. Lots of approaches that you've heard about already today. Sorry. One other aspect that we're looking at that's a little bit kind of maybe new or novel is looking at how cheap off-the-shelf sensors, part of the Internet of Things approach, can really enhance our understanding, both in terms of the variables that drive greenhouse gas production emission at particular sites, but then also how can we then scale this? It comes back to John's comment earlier about the kind of mapping piece and aligning maps with greenhouse gas hotspots and figuring out how we can better ground truth and constrain that. And then finally, we're using some machine learning tools to kind of pull all of this information together into an interactive stakeholder platform that helps to disseminate the work we're doing, but as Shane mentioned, to make it freely available to other academics or scientists or researchers or policymakers that might want to use it for a particular purpose. So some of the preliminary results that we have in the project so far, we've developed a new peatland land use taxonomy in collaboration with EPA and Bord na Móna and National Parks and Wildlife Service. And Wahash has done a really nice job of aligning that with some of the EO data sets that are out there, such as Sentinel-2, for example, to produce the map that you can see there for particular land uses on peatland systems across Ireland. They're also using object-based image analysis techniques to actually, be able to constrain the density of drainage networks across peatland ecosystems. Here you can see an example of a Bord na Móna extraction site and how it can actually really quite, well track the number of drains that are on a site. This gives us real, insight into the drainage status of these peatlands that we can then link to the ecology and the carbon greenhouse gas dynamics, as I've mentioned previously. We're actually on the field, on the ground, making measurements across a range of sites, from the near natural sites you've heard about today, like Clarabog, for example, to some of the more degraded industrial extraction sites, and to some sites that are some way down that rehabilitation pathway, just to better constrain those numbers. And we're using a range of approaches, as I said earlier, from ecovariants to point emissions using chambers, and also, instrumented flumes to actually capture things like the DOC loss, the POC loss, and also quite importantly, evasion of greenhouse gases from water bodies. One thing I would like to make, to reiterate, and many people have mentioned this, is the need for kind of long-term funding for these sorts of measures and long-term data sets. I can see these comments popping up in the chat, which is really nice to see from the audience. And this is really important. Here you can see some data from the Clara Flux Tower that we've had running for the last number of years. And it was set up in an extreme climatic year, low precipitation, high temperatures. The water table dropped quite significantly, and that's what you can see on the left-hand side. And that actually switched the site from a net sink to a net source of carbon. So this really highlights the vulnerability, but also the resilience of these ecosystems to act as a net source or sink of carbon, for example. But it also reiterates the importance of having the long-term data to be able to constrain these numbers and the variability around those numbers as well. As I mentioned, it's also important to look at the other carbon greenhouse gases and carbon losses, for example. You can see some of the methane emissions from the degraded sites we're looking at and other sites undergoing rehabilitation. I think what's really important here, it links back to Ken's point that he made in his talk, is that we need lots of sites to really understand this, because all bogs tend to act differently. And because of that, you can see, for example, the same plant species of Variophorus at both sites acting as very different sources of methane through the plant facilitated transport emissions at each of those sites. We have some preliminary data looking at carbon losses through DOC, for example, through Shane and Lawrence's and Peter's work. And you can see the differences there between losses of dissolved organic carbon from a near natural site versus one that's more significantly degraded. So you can see the sorts of differences there. It's also important, I think, to highlight that we've got some other preliminary data looking at evasion of greenhouse gases from the water bodies, and whether or not it's standing water or moving water or water that's actually going through the flume, for example. You can see the differences there in terms of the emission profile. So again, that's going to add another level of complexity to these sorts of measurements, but it's incredibly important to constrain those numbers in some way, shape or form.
2 minutes remaining, Matt.
No problem. So we're now sort of pulling this information together. So we're pulling the EO data in and aligning that, with some of the ground truth data that we can from the field sites and putting this into our interactive platform. So here you can see kind of the home page, the landing page for that, where you can see a range of sites that we're working on. And then you can also see the sorts of data that's available there, from the mapping version of the EO set data sets from, vegetation classes, for example, but also some of the key data that we have available there, whether that's ancillary data that can be used in modeling exercises, or also the carbon greenhouse gas fluxes as well. So just to summarize, I think, one of the key points that's been made today is really the importance of peatlands in the climate mitigation piece, but they are vulnerable. They're vulnerable to management, they're vulnerable to degradation, they're vulnerable to climatic variability, but we have a huge opportunity now to essentially, put these ecosystems back onto that rehabilitation pathway. We need long-term data to really capture the impacts of changing hydrology and precipitation, for example. And we need to think about, all aspects of the carbon greenhouse gas budget in order to really generate some robust numbers for the reporting purpose. Okay, I'll leave it there, Flo. Thank you very much.
Thanks, Matt. Excellent. Yeah, lots of questions coming in. I'll keep some for the Q&A, Matt, if that's okay, and we'll move on to Bernard Hyde from the EPA is joining us. So far we've obviously talked to researchers and people who have gathered all the data on the field, and Bernard is behind his computer crunching all this data days in, days out, and he's going to tell us more what he's doing for the inventory from the inventory section. Bernard, take it away. Thanks.
Thanks, Florence. Sorry, I just pressed ahead there. Well, unlike most of the people on the line today, I'm relatively new to the whole area of peatlands. In that most of my work done through the years has been in relation to agriculture. However, in the last number of years, I've been tasked with developing our national land use change and forestry estimates. And I'm just going to give a brief overview of how peatlands actually fit into that process. When we talk about land use change and forestry, there's 6 broad land categories: forest land, cropland, grassland, wetlands, settlements, and other land. And the question about there is, where are peatlands reported? And in actual fact, all of the above. And this is where things tend to get complicated. So, for example, forest planted on peat is actually reported under forestry in terms of the LULUCF once it meets the forest definition, and is reported as forestry and organic soil. Similarly, for crops, where there's crops grown on peat, it's cropland and organic soil. Where grass is grown on peat, it's grassland and organic soil. And within the category wetlands, the emissions that are reported within the sector are associated with the harvesting or exploited peat. Pristine peatland, of which we've heard from a number of presenters, there is very little of. We only include the areas. There's no emissions or removals reported, as the basis of national emission inventories is human-induced emissions. So emissions that are caused by human interventions. And this is known as the managed land proxy. Similarly, buildings, roads, etc. on peatlands, these are settlements and organic soil. So you can see from our perspective in trying to get a handle on peatlands, it is very complicated in that peatlands are included in all the individual land uses. What do we report within each of the individual land uses? Well, firstly, we split between land remaining within a land use, so forest land remaining forest land. And
sorry, Bernard, your slides are not showing anymore. Can you?
Oh, sorry.
You went away, or you? Thanks.
Can you see that now?
Perfect.
Yeah, thanks.
Yeah, sorry. Or lands converted to land use, for example, wetland converted to forestry. Sorry, no. In addition to that, we also report at emissions at a level of the major soil types. So for example, this is initially split on the focus of mineral soils and organic soils. We report 5 carbon pools. These are the above ground biomass, below ground biomass, dead organic matter, which includes litter and deadwood, and soils. And the methodologies we use to report these follow those of the IPCC guidelines 2006 and the wetlands supplement of 2014, and a number of people on the line here have been involved in the development of the wetlands supplement in 2014. Other divisions, subdivisions are possible to capture differences due to management systems, climate or vegetation types, and other factors influencing carbon are also possible. And we try our best to use national research studies. However, it will become clearer as I go on through the next couple of slides that we've a lack of spatial information to be able to use the information in some of the research studies. And going back to Ken's point earlier on, studies are generally site specific. How do you then apply those results to other sites? Just kind of give a brief overview of what the emissions and sinks from land use look like. Not dwell too much on it, but currently land in Ireland is a net emitter of carbon or of carbon dioxide to the tune of over 4 million tonnes. Within that, we have a sink from forestry of above 4 million tonnes. But the thing that I will focus on is, as you will see here, there's approximately 7 million tonnes of CO2 emitted from grasslands. And the real story behind this is that of the 330 hectares of grasslands on peat soils, there was approximately 9 million tonnes emitted. Our mineral grasslands sequester about 2 million tonnes, leaving us with a net emission of 7 million tonnes from our grasslands. The wetlands, as I mentioned earlier, then this is the exploited peat areas. And when I talk about exploitation, I'm talking about those at the border Mona lands, those harvested for horticulture by other companies and institutions, and indeed private property. But again, to reiterate what I mentioned earlier, spatial information is lacking.
2 minutes remaining, Bernard.
Thanks. Just to maybe to develop it a bit further, in our estimates, we have a very good system in terms of forestry. It's developed by Forest Ecosystem Research Services through an MOU with the Department of Agriculture. In terms of the other land uses, it's by and large a national top-down approach with limited spatial information available. And as I mentioned earlier, we use national research results where possible. This is, you know, it was a colleague of mine that actually gave me this graphic, but essentially, you know, we're trying to combine national data sets to produce national statistics. It's a mixture of spatial and statistical data, various resolutions and quality. We don't currently have a seamless land use map, and it is actually difficult to resolve conflicts, gaps, duplication, and track real change. So what a process we're involved at the minute is to develop a spatial land use map. And just to reiterate, when I talk about a spatial land use map, I talk about a spatial land use map for reporting purposes under the LULUCF regulations. And not to dwell on it, but if you look on the left here, this is a typical feature of the Irish landscape. It's a mosaic of multiple land uses across multiple scales. And we really have to get down to that fine level of detail to be able to do justice to land use activities in Ireland. In addition to that, you see on the right, we also need to look at this over time, but we also need to layer this land use information with the underlying soil and indeed climatic variables where possible. So to conclude, appropriate land use management and assessment is a vital part of action on climate change. This has been mentioned on numerous occasions today. And I suppose just to finish, there's kind of three main, sentences we generally use in terms of when we're talking about LULUCF, and that's where land management provides to store carbon, for example, forestry, we maintain or enhance it, where it's an emitter of CO2, for example, grasslands and organic soils, reduce or eliminate those emissions. And where land has become degraded and lost its ability, such as wetlands, it should be restored. Thank you.
Thanks, Bernard. And yeah, we're all scratching our heads for you because it is a hard work you have to do without the data and without the information. And there's a few questions I will also have for you after for the panel. So our last speaker today for this session, coming from the UK, Stuart Brooks, is IUCN UK Peatland Programme representative, and will give us some updates from there because they've been busy, very busy bees there as well. And I'm sure we have some message from some lessons from them we could learn. Stuart.
Okay, thank you, Florence. Okay, look, hello everybody. I'm really delighted to be speaking to you. I'm really disappointed actually not to be in Ireland. I think some of my most enjoyable peatland trips have been over to Ireland, and hopefully that'll kind of happen again. I thought I should just say a few words really about the IUCN UK Peatland Programme itself. And I know some of you are familiar with it, but maybe some aren't. And thinking about lessons, there's possibly one or two that we could kind of draw out of the programme itself, its origins, and the approach it's taken to kind of considering how you pull together a really quite a diverse range of people, organisations, institutions across the country to kind of focus on a single issue. So in terms of the origins of the programme, it's been going now for about 11 years. And the kind of principal aim really was to reinvigorate the peatland community and bring it back together again. It's difficult, I think, to kind of think back even a decade ago, but there's so much focus now on peatlands, so much activity, so much interest and so much awareness, but you know, it's not always been that way. So one of the main aims, say back 11 or so years ago, was to reinvigorate that community and bring it back together again. A kind of core purpose within that was to try and bind together, enable some discussion and collaboration between the practitioners, so the people out there actually doing the work on the ground, the scientists, people who are kind of studying peatlands and understanding how they're working and functioning and how they're responding to that management, and really importantly the policymakers. And in that, one of the first outputs really of the programme was to try and bring that scientific community together to try and address, I guess, some of the disputes or lack of consensus around kind of some of the big issues. And again, cast your mind back. I mean, we've just seen some brilliant examples here today of understanding of peatlands across Ireland, where they are, what kind of condition they're in, what they're doing, what they're emitting. But you know, that really kind of wasn't the case. And I'm not suggesting that we've done that and we've got all the answers. But at least we've kind of established a few mechanisms over the years to try and bring some consensus to some of those issues. Because without consensus, I think the policymakers are very reluctant to kind of make progress and therefore kind of make change. A couple of the other elements, I guess, of the programme, which are kind of worthy of mention that you might like to consider. Our conferences, so just as this one here, we've been doing this now annually for the last 10 years, and I think we had about 700 people signed up a couple of weeks ago in our annual conference, so that ran over 4 days, and it's a really kind of great opportunity for the community to get together, and I'm sure you're finding that yourselves here. but even better so when you can kind of physically meet and go out on sites and that kind of thing. So really, really important that we convene our community in that way. The UK strategy, which I'm going to kind of mention in a second, has been the kind of major focus, I suppose, for the programme, not only in the development of that strategy, and we couldn't have done that, I think, without some of the groundwork around the Commission of Inquiry being done. And having that strategy now in place, and the programme now helping the 4 nations of the UK develop their own plans and help to coordinate those to some extent, accepting that we live in a very devolved country where environment is devolved to the 4 nations. And the other, I guess, kind of big thing to stand out through the programme over the decade has been the development of the Peatland Code. So again, not a kind of polished final product, but a significant contribution, I think, to finance. You know, we can't expect the public purse to kind of pick up the full cost of peatland restoration, particularly at the scale that's demanded and required. It's really important, and we're seeing now kind of leverage in from private funding, and the Peatland Code is just one mechanism that might enable that to happen. Okay, so I'm just going to touch on 3 things if I can. So I mentioned there the peatland strategy. So this was published in 2018, and it's quite a rare thing really to have an environmentally focused UK strategy, but it was kind of agreed, signed up to by the 4 nations. And I'm mentioning it here because I think a lot of countries around the world are kind of looking to pull this type of thing together. You know, we've gone beyond, I think, acceptance that there is a requirement for restoration and conservation, and now people are focusing on action. So how do you actually do it? And the strategy really doesn't provide all the answers, but it does provide a kind of useful kind of framework and mechanism for us all, actually, those constituent parts to kind of bind together. And so we've set out in here kind of 6 areas, and again, we're not kind of saying that this is the blueprint, but it's certainly been something which some of the other countries have picked up, not least I think Germany over the last year or so, as a bit of a blueprint to enable development of their own strategies. So
2 minutes remaining, Stuart.
How long, sorry, Florence?
2 minutes remaining.
Okay, that's fine. So anyway, the strategy is online and it's on the IUCN UK Peatland website, and I think a kind of useful reference point, particularly for policymakers. We've just kind of heard some very detailed and very impressive, I think, presentations and analysis around state and condition and monitoring. So I just wanted to kind of raise, an alternative approach, and maybe a complementary one, and one that might be a kind of useful mechanism to involve communities. So we heard kind of community-focused presentation there at Abbeyleix. So again, this guide, kind of simple guide to kind of ad hoc citizen science approach to monitoring the condition and changing condition of peatlands, is something that we're trying to put forward and that could be applied across many sites of different conditions, and go onto the IUCN UK website to kind of have a look at that. And so it's called Eyes on the Bog, kind of very low tech and very easy approach. So my final slide here is just to kind of flag what the programme is doing in collaboration with some of the other kind of institutional and kind of framework organisations, GPI. I think you had Diana Kapansky talking to you first thing this morning, and I'm mentioning it not just because it's kind of an exciting thing that's happening. So a physical pavilion dedicated to peatlands for the first time at COP, and also a virtual pavilion. And I know Catherine Farrell is a kind of great leader for peatlands in Ireland, and Catherine submitted a proposal for showcasing activity and work from Ireland into the virtual pavilion, which is fabulous. I just want to kind of finish really on the power and the value of communication. So go back to the beginning, back to the origins of the IUCN UK Peatland Programme. The reason it was founded, or the reason it was enabled to happen, was that we had a deputy chief executive of BP at the time who was a trustee of a small charitable trust, and he happened to read an article in a national newspaper about peatlands and their potential contribution to climate change mitigation. So he persuaded kind of a philanthropist, very rich person, to kind of speak to the peatland community. So pulled a few of us together, we did that, and we convinced him that actually peatlands was a brilliant nature-based solution to climate change. And that one philanthropist then funded the whole program for the next 6 years. And I think that was just because we were enabling to communicate to a wider public audience about the value of peatlands. So, you know, it's really worthwhile investing in communication. And when you do, good stuff can happen. Okay.
Thank you, Stuart. That was a nice, just finish on a positive. We might have a philanthropist listening to us today.
Yeah,
who knows?
let's hope so.
Let's hope so. Thank you, Stuart. So maybe I'll call on all our panelists to maybe turn on their cameras for the questions, and I have gathered a few here that I'll start with. So I suppose something that came across all of your presentations and throughout the questions and the chat is that we need to inform policy, we need robust evidence, and for this to happen we need a lot of local, like, you know, studies in Ireland that represent studies like Irish conditions, and it has to be representative, and it has to be inclusive. So we need to represent everything. There was a question on, for example, we have a very Irish typical case of an abandoned cutover sites. You know, do we report those? That's a question for Bernard actually, or Ken, but I think Bernard might be answering that. I don't. So a cutover bog, if it's managed, I guess it is going to be reported. But if it has been abandoned, so for how long, I guess, is going to be the question. Is that right, Bernard?
Well, sorry, but the host has controlled my video. I can't turn it back on. But look, at the minute, due to the lack of data, we don't have a very good sense at a local level on this. But yes, once there's been a human intervention, it's managed. And
so, you know, abandonment is not, though, abandonment.
Well, abandonment it was abandoned after human intervention. It was a human decision to abandon it. It's a human decision to re-wet. So emissions from re-wetting are included, will be included. Or, you know, if we ever get to the stage in my lifetime of turning those re-wetted areas into active sinks, those sinks will be reported. And this is the whole issue around the managed land proxy. Once there's a human intervention, regardless of what that is, it's managed.
Thanks, Bernard. And there was a couple of questions on the I can actually answer that, the nutrient-rich, nutrient-poor sites, because again, that's another an Irish phenomenon. If you have a raised bog, you typically have a nutrient-poor peat, but because it's been cut over, or Bonamona has cut the top, you end up with the bottom layer of the peat. We call them reed peat, which are actually fen peat. They were like the original formation, so they're fen peat. So they end up to be nutrient rich bog. I know it's a kind of a difficult way to address the situation. So the simplest way we've been using it with the IPCC wetland supplement and in our paper is to actually use the N, like proportion of N. So nutrient content, nitrogen content. So if it's around 1%, it's nutrient poor. Anything above 2, it's nutrient rich. And that site in Lanesborough, that site was nutrient rich. It had more than 2% nitrogen, but also, of course, the farmer had fertilized the land as well, you know, so that comes in. So I hope that answers those questions from Vitus and Paddy, I think, had the question. There was a question for Chris about whether the environmental pillars could form, and that's actually something could form a network for bog restoration communities. So I think that question links to what is the future now. I mean, we have this Peatlands Gathering. We've discussed already at another the Water Forum earlier in the year that we need to put all this information together in one place for the public, and Stuart has given us example of how they do it in the UK. So what's next, Chris? What do you think? How can we do that?
Yeah, the question was whether the PPN and the environmental pillar, which is the community groups, can form a network. My answer is yes or no. The PPN is a structure where they can encourage community groups to get involved with their natural habitats. The environmental pillar is basically just those community groups that is affiliated to the Irish Environmental Network or individuals. What is missing in Ireland is the gap between community groups and academia and the big multi or semi-state bodies. We don't have, like the UK and Germany and Belgium and all of these places, a strong ENGO sector that is directly involved in restoration work. And I would love if we can get the Irish Environmental Network to get involved, some of those people, to get and start engaging in active restoration work with all the other stakeholders. That is missing from this whole peatland gathering today. And I wish we can solve that issue.
Thanks, Chris. Yeah, that will be a key message we're going to report tomorrow to the panel. That's actually a great point to end with. But there was another question for Shane. If you're still here, Shane, because I think it's a very important one to communicate. The Goldilocks water table zone. So, you know, we're talking about rewetting and how we can sustain that. There was another good question about can we do that for how long can we do that for really? But can you tell us more about that Goldilocks water table zone?
Yeah, well, you find it in studies all across the world and in Ireland too. I mean, where you have a nice expansive sphagnum and it's quite deep, the water table is quite stable and consistent. So it fluctuates in and around 20 centimeters. And we found at Clara that it's always at the summer ground level, because where you have a bog and you have sphagnum, it goes up and down, it oscillates. So even in the summertime, it's kind of close to the ground level. And that's kind of what we aim for in restoration. Now in practice, that's really, really difficult to do because you don't have the sphagnum, or it's sometimes called an acrotem, there anymore. So you're dealing with a different structure, a different peat structure. So in restoration work, you find that fluctuation is larger, might be 30 to 40 to 50 centimeters. But in time, it will get to that 20 centimeters. So to answer the question, the Goldilocks zone will be the 20 centimeter. But once it's gone, it's gone. And in reality, it probably take tens, hundreds, if not 1,000 years to get something like that back.
Yeah. Thanks, Shane. And final question for you, Matt. It was a question from Patty, I think, to do with the when you mapped the drains. I think it was RD Gullion. Yeah. Was it just the fact like where they are, but can you actually tell the depth and their functional status?
Not directly at the moment. It's something that we are kind of thinking about and working on. So the data set that's used there are some of the kind of high resolution multi-spec data that we have that can give us really kind of high resolution information on the drains. And so once we've got essentially the kind of the machine learning approach, the model in to actually be able to detect the drains, what we're looking to do is whether or not we can then apply some sort of status of activity there, you know, in terms of the activity of the drain, in terms of, you know, of still, you know, pulling or allowing water to drain out of the site. But at the moment we can't, you know, we couldn't pinpoint, you know, for example, the depth of the drain. with that information. I don't know if it's really John Connolly's work and Wahaj's work as well. It is, like I say, it's something we've discussed at our steering committee meetings. I'm not sure if either of them are on the panel or in the audience at the moment. If they are, do jump in and provide some comment. But at the moment, no, it's something we're trying to look at in a more kind of proxy-based manner, perhaps.
Thanks, Matt. I don't think they're on the panel at the moment. So I think that will conclude. I had one question for Stuart, really on, well, yeah, which links back to Chris's point, is that what are we? How did you get to have the academia linked all the data to be to bring citizen science in as well? We have a much smaller community of either. So any advice to move forward from, I suppose, from where you were 10 years ago or 5 years ago even?
Well, I mean, I'm not sure, to be honest. We're kind of any further on. I think, some of the scientific work that you've just been sharing, I think is fabulous. And it's a work in progress. The Eyes on the Bog is just a contribution, I suppose, to the monitoring effort. So and it's really just now rolling out on the ground. So I wouldn't want to give the impression that we've got a network in and we're taking in the data and it's all kind of being fed into some brilliant machine. I'm afraid that's not happening. It's not happening yet. And I don't know whether we'll ever get there, but I guess it's just trying to respond to a need. And we've got all of this kind of great activity and great science happening, and obviously the potential for remote sensing and the development of that. But I know as an organisation ourselves, we're just in the process of undertaking a full natural capital assessment of all of our peatlands. And at the end of the day, it still comes down to us needing to understand what the condition of those peatlands are in order to feed the model. So, there's no easy solution, I'm afraid. I think it's just a case of having kind of multiple approaches and the coordination, I guess, the effort and the fact that we have an IUCN UK peatland programme possibly it enables that coordination to be more likely. It's not a guarantee, but we at least have the ability to convene the 4 nations and have conferences like this. So I think without that kind of binding agent, the glue, then it's never going to happen. So maybe we're all working towards the same aim, and if the Irish peatland community, I think, can ensure that it stays together, then I think you kind of be more likely to get to the point where you're trying to get to, which is a kind of nationally coordinated activity and sharing of information.
Yeah, we're missing the glue. We don't have an IUCN, obviously Irish branch, but maybe that's something we should be working on. On that, thanks a million. Thanks for all the presenters, really. And session 4 now is officially closed. We can reconvene at 2:45. So that's 2:45. I think I read that. No, 3:45. Sorry, 3:45. Yeah, sorry, 3:45 for the final session. So welcome. Yeah, thanks again, everybody and the audience for the questions, and we'll see you in about 20 minutes or so. Okay, thanks.